Now imagine this, you're sitting at your desk texting a friend on the other side of the world. You hit send and bam! The message arrives almost instantly. It feels like magic. Like the internet just teleported your words across the globe. But here's the twist. It didn't. Not even close. Your message didn't travel instantaneously. It had to obey the universe's ultimate speed limit. In fact, it's physically impossible to send any kind of information faster than a certain speed. And no, we're not just talking about bad Wi-Fi or network lag. We're talking about something much deeper. A law of nature so fundamental that even light, the fastest thing in the universe, can't break it. So, why can't information travel faster than that? Why not just press a button and have a message pop up instantly anywhere? Or better yet, why not build a telepathic internet that beams thoughts in real time across galaxies? That would be amazing. But the universe says, nope. And the reason why is surprisingly beautiful. Let's zoom out for a second. In our daily lives, we often treat time and space as separate things. Time is what your clock measures. Space is what you walk through. But back in 1905, a young man working at a Swiss patent office, yes, that Einstein, proposed something radical. Time and space aren't separate. They're woven together into something called spacetime. And here's where it gets wild. Nothing, not even a thought, a light beam, or a cat meme, can move through spacetime faster than light. But wait, why does that matter for sending information? Imagine you and a friend are standing far apart on a football field. You want to send a message. If you shout, sound waves carry your voice through the air. That's slow. So you get clever and shine a flashlight in Morse code. Now your message travels at light speed. Much better. But here's the catch. Even light takes time. From New York to Tokyo, about 0.07 seconds. From Earth to Mars, up to 20 minutes. And the universe? Well, it's big, very big. So even at top speed, information needs time to get from here to there. Now here's the brain bender. What if we could somehow cheat this? What if we could beam information instantly, like truly instantly, without waiting for light or anything else to travel? That would be faster than light, right? Sounds cool, right? Problem is, it would also break causality. And breaking causality breaks reality itself. Let's dive deeper into this idea of causality. Imagine you're playing a game of billiards. You hit the white ball, it rolls across the table and knocks another ball into a pocket. Cause and effect. Your action leads to a result. But what if the second ball moved before you hit the first one? That would feel wrong. That's a violation of causality. And the universe doesn't like that. It's not just about breaking a rule. It's about making the entire timeline of events unstable. If you could send a message faster than light, some observers, moving at different speeds, might see the effect happen before the cause. Which means theoretically, you could send a message back in time. And if you can do that, you unlock all kinds of paradoxes. Like the infamous grandfather paradox. You send a message to the past warning your grandfather not to meet your grandmother. That changes the future. You're never born. But if you're never born, who sent the message? It's a loop that breaks the logic of reality. This isn't just sci-fi, it's a serious implication of faster-than-light communication. And that's why the universe seems to have built-in safeguards like a cosmic firewall against it. Now you might say, but wait, aren't there weird quantum effects that look like information travels instantly? You've probably heard of quantum entanglement. Two particles separated by light years seem to affect each other instantly. Einstein famously called it spooky action at a distance. So, is that our loophole? A cosmic cheat code for instant messaging? Well, not quite. Entanglement is bizarre, yes, but it doesn't actually allow information to travel faster than light. Here's the key. When two entangled particles are measured, their states are correlated, but you can't control what result you get. It's like opening two random fortune cookies on opposite sides of the universe and seeing matching messages. It's amazing. But you didn't send a message. You just noticed a pattern. To use the pattern to actually transmit information, you'd still need a regular, slower-than-light channel. Let's build an analogy. Imagine two friends, Alice and Bob, agree in advance to each flip a coin at the exact same time, no matter where they are in the world. If Alice gets heads, Bob will also get heads. But neither of them chooses the outcome. They can't control it. So while the match feels instant, no real message was sent. That's entanglement in a nutshell. Magical in its correlations, but silent when it comes to communication. So we're back to our universal speed limit. And yes, that limit is the speed of light. Roughly 300,000 kilometers per second. It's fast, but not infinite. And more importantly, it's not just a technical limitation. It's a structural feature of how space-time is built, a kind of built-in rhythm to reality. So, if nothing can move faster than light, not even information, how do we communicate across such vast distances in space? Let's put this into perspective. Imagine Earth and Mars. When they're closest, they're about 55 million kilometers apart. That means a message, even traveling at light speed, takes at least 3 minutes to arrive. When they're farthest, that delay can stretch to more than 20 minutes. That's not ideal for real-time conversations. But it's the best the universe offers us. We've simply adapted. This is why NASA doesn't drive the Mars rovers like remote control cars. The delay is too long. Instead, they send instructions in chunks. The rover executes them. Then, a while later, it sends back what happened. Every command has to be pre-planned. Every photo is from the past. When you see a new picture from Mars, you're looking at something that happened minutes ago, even though it feels instant on your phone screen. This isn't just about space, it's about time, literally. Now, here's a fun twist. The speed of light is so foundational that it's actually baked into the definition of distance itself. In 1983, scientists redefined the meter. It's now based on how far light travels in a vacuum in 1,299,792,458th of a second. That means the meter isn't just a stick in a museum, it's a measure of light's own pace. So when we talk about sending signals at the speed of light, we're talking about something that's tied directly to how we understand space and time. To go faster would be like trying to outpace your own shadow. The concept breaks down. Still, people ask, can't we just bend space somehow? What about wormholes or warp drives? Could those let us cheat the system? Theoretically, maybe. These ideas exist in equations, in math, but there's a huge gap between what's mathematically possible and what's physically achievable. Wormholes require exotic matter with negative energy. We've never seen that in nature. And even if it exists, keeping a wormhole stable might take more energy than exists in the entire galaxy. It's like having a shortcut on a map, but no road to actually reach it. So we're back to this fundamental truth. Real information, the kind you can choose, encode, and send, moves at a limited speed. Not because we haven't built fast enough machines, but because space-time itself won't allow it. It's the structure of reality, like gravity, like time. A built-in rule that everything must follow, from quarks to galaxies. And here's the beautiful twist to all of this. The very fact that we can't send information instantly isn't a bug of the universe. It's a feature. It's what keeps cause and effect in order. It's what prevents paradoxes where a message could arrive before it was even sent. This limitation protects the consistency of reality. If information could travel faster than light, you could, at least theoretically, send a message into your own past. That breaks everything. The laws of physics, causality, and even your favorite science fiction timelines. This is why no matter how much we innovate, invent, or imagine, we're all still playing by the universe's rules. Fiber optic cables, satellite relays, quantum encryption, it's all incredibly fast, but never instant. Even in the quantum world, where particles can become entangled and influence each other across distances, the actual transmission of usable information still obeys the speed limit. Quantum entanglement is strange, but it doesn't let you send messages faster than light. That's not just a technical limitation, it's a fundamental one. But here's the part that should make you smile. This boundary isn't the end of curiosity, it's the beginning. Because once we accept the rules, we can start asking better questions. Like how to design communication systems that work within these limits, or how to understand space and time not as barriers, but as the fabric of the story we're part of. The story of a universe that doesn't allow shortcuts, but rewards understanding. So next time you send a text, make a call, or watch a live stream from across the planet, take a second to appreciate what's actually happening. Billions of electromagnetic waves bouncing between satellites, cables, and servers, all racing at light speed just to get your message delivered a fraction of a second later. It's not instant, but it's close enough to feel like magic. And if you want more moments like this, those little aha sparks where the universe suddenly makes sense, then you're in the right place. Like this video, share it with someone curious, and subscribe to How It Actually Works. Because the more we understand how the universe plays its game, the better we get at playing along.